Consider an object that's at the same time moving linearly and rotating. In other words, combining rotational and translational motion, like this ball here that's shown here. We have the bars to try to show us the center of mass at the middle. As it rolls, as it's going to go like this, its center of mass is going to be moving linearly, but then it's going to be rotating about the point where it is in contact with the ground. That point, let's call it point P, is held by static friction. Without static friction, the ball is going to slide instead of rolling. Now, what you need to remember, at any instant, all parts of the wheel are going to rotate about point P. And they all have the same angular velocity about that point P. Now, for an object that's rolling without slipping, the velocity of the center of mass is related to the angular velocity through this expression. V center of mass is equal to R times omega. The acceleration of the center of mass is related to the rotational acceleration by R alpha. A center of mass is R alpha. That's for an object that is purely rolling. That's rolling without slipping. Now, when that's the case, we have two types of kinetic energy. The object is rolling about itself, so it's going to have rotational kinetic energy. That's 1/2 of I relative to the center of mass times omega squared. Plus, since it's moving linearly, it's going to have linear kinetic energy, 1/2 of mv squared, where v is the velocity of the center of mass. So because the object is doing both, is rotating and moving linearly, we have two types of energy of motion, rotational and translational, and we have to account for both. Now, notice here, this is the same expression that we just had, but because the velocity of the center of mass is related to the angular velocity through this expression, we can rewrite the kinetic energy equation by replacing here V by R omega as such. So then my expression, for example, here is 1/2 of I center of mass plus mr squared times omega squared. Of course, we could have done it the other way, and we could have written it as 1/2 of I center of mass plus mr squared. V is going to be R omega, so omega is V over R, so that's going to be V squared over R squared. So both of these would work. And there is a benefit of writing them out that way sometimes.